Okay, so I can't see anything, so but so yeah, I'm going to show you how you can incorporate Redis to your toolbox, so you can have more fun when developing your Ruby applications. Of course, I would like to thank the sponsors. In the meanest one way, this conference is great, so the sponsors are great. That's me, Javier Ramirez. If you forget the name, it's in the back of your T-shirts. Yeah. That's my Twitter handle, supercoco9. So if you have any questions later, just feel free to ask me. If I don't know the answers, I can just point you to someone that will know. And Tiawaki is the company I'm building. It's a startup for developers to make happier developers. And it's the project in which I've learned most of the things I'm going to tell you today. But before we start, it's Friday. And I was thinking, Friday, Ruby conference, should we do the Friday hack? Hooks! Nah, hooks and hacks, they don't match well. Next thing you know, someone is going to need surgery. And when I think of surgery, I think of doctors. And doctors wearing gloves and scrub caps and surgical masks and washing their hands like crazy because everything has to be really clean. Because if it's not really clean, maybe you could get an infection and you could die. And you think, yeah, of course you could get an infection and you could die. That's so obvious. It wasn't that obvious until the end of the 19th century, actually. Before that, doctors and people studying to be doctor will be doing autopsies, what we call reverse engineering, like dead people. So they will be hacking around the organs with their bare hands, in the dead people. And then with the same hands, without washing or anything, they will operate people and they will help mothers deliver children, those same hands. Of course, the mortality rate was really high. And it was this really smart guy who said, I'm not sure if it's such a good idea to be hacking around dead people organs and with the same hands just going and operate people. I don't know, maybe we could wash our hands between one thing and the other. And he did some tests in Vienna in 1840-something. And he got the mortality rate, it was lower by 70%. So it says, oh, this guy is a hero. Well, he should be a hero, but all the other doctors said, washing our hands, are you crazy? I mean, we've been doing this shit for years. It's working fine. Well, people are dying. So what? Is the way medicine is. People die because science is not perfect, blah, 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 whatever. What I want to tell you with this is when you are an expert in something, when you have been doing the same thing for a long time, it's really difficult for you to change your point of view and to embrace new practices. So one of the things I want to do today is telling you that some of the things that you learn are OK, but there are also other things that maybe might improve how you do some things. If you are like me, when you were, I hope you are not like me, but if you are like me, when you were learning how to do programming, you were working with relational databases, which are amazing. But then if you are like me, you have some preconceptions like, OK, if my application is slow, the first thing I'm going to check is my database, because for sure that's the bottleneck. We all know that. And it happens to be the case often with relational databases, because relational databases are quite complex. You store information in different tables without any duplication whatsoever, and you store the information always in that tables. And then you can query those tables in a lot of different ways. And the database engine has to do a lot of work for retrieving that information. And yeah, sometimes they can be slow. And since they are slow, you are limiting yourself to saying, I shouldn't store some things. If I'm making more than 3 or 4 inserts in a request, I'm doing it wrong. Today I want to tell you about Redis, and in Redis, this is a bit different. You can get easily 500,000 inserts per second on a single machine, with 500,000 inserts per second. Most of you will be happy if you have 500,000 visitors a month in your applications, 1 second, 500,000 inserts, more reads. It's like, okay, not bad. So some of the things you had in your head, like writing things to a data store is slow. It depends what you call slow. And then you can tell me, okay, so this Redis thing is fast, but it's just for caching, like main cache, yeah? Yeah, you can use Redis for caching, and it's quite good for that. If you are only using it for caching, it's better that you use main cache. Main cache is better for caching than Redis, actually. It's as fast, kind of, and it has different things. But with Redis, you can do more things than just caching. You can do things like you can persist the things to disk. So when you turn off the machine and you start again, the things are still there, which is quite cool. You can replicate things like master-slave. You can do a lot of interesting things with apart from caching. And you tell me, of course I can do more things with Redis. I can do queues, because everybody is using Resque or Sidekiq or Ost for using queues with Redis. That's true. You can also use Redis for making queues, but sending things to background processing. But it's not the only use case that you can do. And I will bet most of you, if you are using Redis, you are using Resque or Sidekiq. Anyone using Resque, Sidekiq? Okay. Of those of you, are you using Redis for any other thing apart than from not that many? Yeah, you are in the right room. So, what is Redis? Redis is this thing. It's an advanced key value store, but it's not just a key value store. You just don't keep, this value to this key, but it supports different data types, which is amazing. You can store a list that will be like arrays. You can store hashes. You can store for strings and numbers, and you can store sets and sort sets. So basically, you can think of Redis like, imagine you have a hash table in your Ruby application. So imagine you take that hash table and you put it like on a distributed server in which different processes can be accessing the hash table and doing hash table operations the way you will do. And then you can persist that to disk. Or think of an array. So think you are sharing an array with other processes. So that's the kind of things you can do with Redis. You can take your data structures, put them out, share them between different processes, and persist them to disk if you want, and it's really fast. So it's like, okay, it's like a data store, but it feels more like your data structures, which is like, oh, I like this. Abdi and Hanno yesterday, in different talks, they were saying that, the hacker in you, it's an important part of what we do, like being happy, hacking around, doing things. So when I am working with Redis, I feel quite hackerish, like I'm having like my list and my hash tables and my sets and different things. And also the thinker, it's quite happy too, because you have like this master-slave thing, and it's really fast and performant and everything. So you can, you have like two things together. So working with Redis feels really nice, at least for me. But I like it also because it has a manifesto. It's quite interesting. It's the first data store I know with a manifesto. And this is like blah, 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 blah. But these 3 points, those are amazing. Code is like a poem. It's like, whoa. We are against complexity. We optimize for joy. When I met Ruby a few years ago, it was one of the things I like. It's like Ruby is optimized for programmer happiness, and Redis is optimized for joy. It's like, it resonates with me. It's such a perfect match. It's such a perfect match that if you go to the Redis webpage, Redis.io, that's coming, the webpage is made in Ruby. It's using the framework Cuba. So the creator of Ruby, actually, he used Cuba or Sinatra usually for doing his things when he's doing like web applications. Because they really go well together. So if you like Ruby because it feels like easy and blah, blah, you're going to like probably Redis. How does it feel to work with Redis? I don't want to tell you everything you can do, because the documentation actually is quite good. I just want you to get an idea of how it is. But yes, setting values is as easy as it gets. Yes, okay, put this value into this key, get the value, but you can do interesting things. Like you can get, the same way that with a string you could get like a subset, you can do that to here, which is like, a twist when you are thinking in other database. You can do interesting things with this thing. If you have like fixed length data, you could put them all in a huge string and then get the data, separately. That's a common pattern in Redis. Working with list will be like arrays. You can just, push information to the list, to the right or to the left. You can pop information from the list, or you can, just ask about the size of the list, removing elements, whatever. Actually, when you are using Resque or Sidekiq, this is all you are doing. You are just pushing elements into a list, and then the worker is popping elements from the list, and that's it. So if you want to implement a list or a stack in Redis, it's quite easy. Just 2 instructions, nothing else. Counters, like incrementing, decrementing counters. It's also quite easy. It's like, hey, counters are so boring. I'll tell you later. Counters can be interesting. And you can also decrement the counters, not just increment. That's complete. And hashes. You can work with hash tables, with hashes here. And you can work at the attribute level, set this attribute of that hash with this value. Or you can, give me all the attributes for this hash table, and you can get them all. So, you can also have like hash structures in Redis. I'm going quite fast because it's really easy. I mean, it's like nothing too special here. I just want you to see that working with this, it's very easy, but it's quite powerful. You have sets. Sets are really interesting. Imagine when you have to do something like, I have a list of followers, and I want to see who am I following and who are you following, which are our common followers. Doing that in a relational database will be like, OK, I'm going to query this table, and I'm going to join with the same table again, where the ID is my ID, and the other ID of the alias of the table is the other, and put them together. It starts to get messy. If you want to do the things like, give me all the friends in common for 50 different people, good luck with that. In Redis, it's just, OK, give me the intersection of this set and this set and this, and it's like, OK, here you are. That's what Twitter is doing, by the way. It's quite easy to do this kind of operations. If you want to see really, really interesting example of what you can do with sets, I recommend this post by Thoughtbot. And they have an interesting example. It's not real life, but it feels like if it were, about having timetables of flights departing from one city and from the other, and saying something like, give me all the flights from San Francisco to Madrid next week between 11 a.m. on Monday and I don't know when on Wednesday. And with Redis, it's like maybe 5 lines of code, and it's like, quite fast. So it's impressive when you know what you are doing. Why Redis is so fast? Well, it is so fast because everything is in memory all the time. And by everything, I mean everything. Your whole data set is in memory all the time. And you can tell me, oh, of course, if I put my whole Postgres or my SQL in memory, it's going to be really fast. Well, it's going to be much faster than if it was on disk, but it's not going to be much faster than this. There are some use cases, like Instagram, for example. They were getting the limit when working with MySQL, and putting Redis was like 60 times faster. So still, even with everything in memory, relational databases are much slower than this. But yeah, everything is in memory all the time, and you need to know this. Because if you don't know this, it's going to be hell. I mean, if you are trying to put more data than memory, you are out of luck. So everything's in memory all the time. And you are saying, if everything is in memory all the time, what happens when I turn off the server and start again? Well, you have persistence by default. It's something called RDB, something like RedisDB, which is like a binary format. Basically, it's a snapshot of the memory. RDB is like taking everything which is in memory now, put it on disk, on a file, on a binary format, and that's it. This is used for replication, for backups, blah, blah, blah. By default, you get this every 5 minutes. So if the server crashes, you are losing 5 minutes of data. Maybe, I mean, for some application, that might be perfect. I don't care, 5 minutes of data. If I'm using Redis for something kind of an intermediate store, that might be fine. But if you need something more, you can use something which is called AOF, which is the append-only file, which is like a text file in which basically every time you are sending a command to Redis, like set this value, union, this whatever, what it's doing is storing that command in a text file, almost in the same format you're sending it. So you take that text file and you reply the same thing in another server. You get exactly the same status, but going command after command. So it's like, okay, start from scratch, insert this, then do this, then do this. So replicating that can be slow. But the thing is, this format file, this file, it's quite safe. By default, if something is wrong, you are going to lose only 1 second of data. You can go down to half a second of data that you could lose in case of a catastrophe or something. With half second of persistence, Redis is still quite performant. You can get like huge numbers. If you want to make sure that you are not losing even half a second of data, there are some things you can do. You can use replication. So doing replication like master slave in Redis is really easy. You only have a Redis working, and you can start, if you start another Redis and saying, OK, start this Redis, and it's a slave of this IP and this port, that's it. You don't need to do anything else. You have replication. So you can start like as many slaves as you want, and you will have like a master for writing, all the others for reading. That's the way like most people are doing replication when you are not like a huge installation of Redis. If you need something bigger, then you go with Sardine, which is basically you have a lot of masters, and depending on the key, you are sending the request to one or the other. It's exactly the same thing you are doing in Memcache when you have several Memcache servers, and you are hitting one or the other depending on the hash key. And this is what a lot of big people like Pinterest and these kind of people are doing. And if you need something even more transparent, there is something called Swarm Proxy, which is a proxy for Redis and Memcache programmed by Twitter. Is the one they use internally. So you talk to the proxy, and you have like a lot of servers, but everything is transparent for you. You just talk to the proxy, and that's it. And if you wait to the end of the year, Redis is going to have a Redis cluster, like is now in development. It's going to have Redis cluster like officially. So if everything goes wrong, you will lose maybe a few milliseconds of data. And a few milliseconds of data is already like, quite acceptable for most applications. Another interesting thing about Redis, it's, I'm sorry, but the hat is like, too much. Another interesting thing about Redis is, all the operations are atomic. Redis is a single process, single thread, written in C, no C++ or anything, just C, single process, single thread. So it's impossible that you have any concurrency problems because there is only one thing happening at the same time. So basically, if you need to synchronize different processes and you don't want to start thinking of concurrency, I need to be thread safe, blah, 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 whatever, you can just use Redis for synchronizing different processes, and you are sure the operations you are doing are always atomic. You never have any problems. Imagine you need to increment a counter for a sequence, and you have like 3, 4, I don't know how many processes. Just incrementing Redis, and that's it. You are never going to have any collisions. Adding to a list, taking away from the list, whatever. So it's quite good for that. And if you need to group like several commands in a single transaction, there is a way of doing that too. Some things that are quite funny about Redis, you can use scripting with Lua inside of Redis. It will be like the equivalent of running store procedures on a database, but you are using Lua. And Lua is also quite fun. It feels like hackies. It's like, yeah, I'm doing something in Lua. Yeah, it's crashing. Wow, it's amazing because I don't know any Lua, but you are running a script that you are sending from Ruby. You send the script to Redis, and in Redis says, okay, I'm sending you this script in Lua. just run the script inside of this Redis thing, and give me the results, and it's like, it's working. It's like, wow, and it's fast, and really, and you're like, what am I doing? I don't know, but it's really, it's crazy. And you have to try this. I mean, really. But the thing is, so yeah, you can use Lua for doing atomic operations or for doing things that are not even allowed originally in Redis. But just Lua is a programming language, so there are many things you can do. Have to be careful because it's going to be also like atomically. So if you go like you make like a huge Lua script, maybe you are going to to start hitting performance problems. Something that people are doing is they have a master, and then they run the Lua scripts on the slaves only. So the master is always performing well, and and they are only running in the the Lua in the slaves. So if they are not as fast, that's fine. So there are a lot of interesting things you can do here. Okay, but what's being used for? How other people are using Redis? Because I'm telling you what it is. I'm telling you the kind of things you can do, but is this useful? I mean, apart from being like fun and blah, blah. Yeah, it is. Twitter. We all have Twitter. Every time you are checking your timeline on Twitter, it's coming from Redis. So basically, Twitter is this site which is like on average, every second, they have like 5,000 tweets. Like they are writing 5,000 tweets every second on average. On the peak hour, it's like 7,000. When there is something like the Super Bowl or my talk, then they have like 12,000 tweets, inserts per second. That's inserts. Reads are about 300 and something, 300,000 queries reads per second, and 5,000 inserts per second, like all the time. In August, something's happened in Japan. They put like an old manga TV series or something on TV. Japanese people went crazy, and they had 140,000 inserts per second. And it was working. It was like, yeah, I don't care, that's fine. So, it's interesting. So what they are doing basically is this. In Twitter, when any client, the web application, API, your phone, whatever, when they are using the Write API, what this do is, okay, there is a fan-out process, which is basically FlockDB is like a GraphDB, and they are saying, okay, let's imagine I'm Katy Perry. Yes. Let's imagine that. Okay. I'm Katy Perry, and I have 39 million followers. So basically what they do is they come here and say, okay, how many followers you have? 39 million. No problem. For each of these followers, I'm going to insert in Redis. So Katy Perry says, hi, I'm Katy Perry. And it's like 30 million inserts on Redis in that moment. So they do, okay, let's go into insert in the 39 million timelines of the users, let's go into insert this. That's not really true. They use write push if exists, which means push to the timeline of the user only if the timeline exists, because they keep in Redis only the active timelines. So maybe of these 39 million users, maybe 2 million, they are not active, they are not using Twitter, so they don't have that on Redis. They only have that on database because they don't have to use all the memory. Still, it will be like potentially 30 million inserts in Redis, and they store only the ID of the tweet, 8 bytes for the ID of the tweet, 8 bytes for the ID of the user doing the tweet. They don't store the whole information because everything is in memory. You have to be careful. You should be thinking of compacting things. It feels like the old times. Like, I have to put as many things as possible in just 8 characters. Yeah. So that's the kind of thing you are doing because, it's expensive. So they keep the ID here, the other ID, metadata. Is this a retweet? Is this a reply? Whatever. So that's for the insert. When they are going to read, it goes to Redis. From Redis, they are saying, OK, this is the ID. Give me the user information from Memcache, and give me the tweet information from Memcache in case the tweet has been done in the last month and a half. It will be on Memcache. If it's older than month and a half, it will be directly on MySQL. So that's how it works. So Kate Perry says, hi, 39 million people are getting on the timeline the update, and the longest that they have to wait is 5 seconds. And the funny thing here is when Kate Perry is saying to Rihanna, I like your hairstyle. That's amazing because it's like 30 million followers and the people following the other is mind-blowing. And by the way, they are replicating this into 3 different servers just to be safe that everything is working fine. So you do the math. It's like, so Twitter are using the Redis for this. And they are using it for this because with MySQL, it was impossible, this kind of performance. It was like, no way. Pinterest. Pinterest is this thing which is really cute, and you are posting pictures, usually not of cats, which is quite unusual. So you post pictures of other things like food and, I don't know, beautiful people, doors, whatever. And yeah, that's Pinterest. And you can, no, it's exciting, eh? And no, it is actually, the numbers are mind-blowing. Like 40% of the traffic that e-commerce, I mean, when you're in an e-commerce and you say, like, share this product, 40% of the shares are now in Pinterest. They used to be on Amazon. Pinterest is already bigger on that sense. So Pinterest is really huge. I have the numbers there, which are like, they have like 500 app servers, about 90 MySQL servers replicated with another 90, over 100 Redis instances, 200 memcached. Yeah, it must be expensive, the server bill every month. But the thing is, they changed from MySQL and memcache to Redis, and they saved 30% in input-output operations by changing this. And the interesting thing of Pinterest is I want you to see how they are using, how they are structuring the information. It's like, per every user, they are keeping a set, a sort set. A sort is like, it's sorted, but anyway, it's a set, in which they have basically all the users that you are following. And since this is not a relational database, this is a NoSQL, if you want to store relationships, you have to do the relationship yourself. So they are keeping, OK, I'm following these users, and then these users are following me. You see? It's like one and the other. So if you want to have relationships in NoSQL store, you need to do them yourself. These are my followers. These people are following me. Yeah? Because that's why, this is much faster. Any non-SQL store is much faster than a relational data store, because relational data stores are able to do this both ways with indexes, blah, blah. Here, you don't have indexes. Or you can think like every list is an index itself. So, you have to do the things. It's like you really need to hack around and know your way about what you are doing. So, yeah, they're basically storing which boards I'm following, which users I'm following, the other way around, and that's it. And with this, you have Pinterest working. Every time you hit Pinterest, the timeline is coming from Twitter. The structure they have internally is quite similar to the one of Twitter itself. Viacom is this huge television network. They have Paramount, Comedy something, NTV, Comedy Central, Nickelodeon, a lot of things. And they started using Redis because they wanted to have a cache, but they wanted to do like fancy things with the expiration of the keys. And expiring cache is quite difficult. So with Redis, it was not that difficult to do fancy things with the expiration of the keys. So they started as a cache. And then they said, yeah, this is working fine. So let's go into use it also as a queue. Yeah, it's quite impressive. It's working fine. And then they said, this is a television channel, and television channels have things like, OK, Breaking Bad is ending, and you have like 200 billion people like at the same time commenting, oh, no, my God, the end is. So I'm not going to say it. But the thing is, a lot of people at the same time. MySQL was unable to handle that load. So basically, what they're doing here, which is quite a common pattern, is they are checking off the load of the moment, they are putting it into Redis. So every time you say, I like this, I hate this, whatever, I'm watching this, it goes to Redis. And Redis is quite performant, so it's there. Every few minutes, what they are doing is taking the information from Redis and putting it into MySQL. But instead of making a lot of inserts to MySQL, they take like a chunk of information from Redis, they put it to MySQL. So MySQL can handle that. And then you can have all the relationships, everything. The relational databases are good. They are quite amazing for what they do. So a common pattern is, OK, put Redis in the middle, take things as an intermediate store, and then just put the things on the database, but you are checking all of the heat from the servers, which is amazing. Also, remember, in Redis, everything is on memory, so it's quite expensive compared to a relational data store. So this way, for a few minutes, you have everything in memory, but then you are offloading to disk, clean the memory, getting more things. It's a quite efficient way of working. It's how they do things here. And you might be thinking, but for doing this, I need a lot of memory. Well, you might. If you are Twitter, you have 10 terabytes of memory for Redis, whatever. But OpenRedis is an interesting service. It's run by a guy from Argentina, Sobran. It's like Redis as a service on Amazon. So basically, you can just, instead of having your own servers, you can just use OpenRedis and forget about it. It's like I connect to this port and I'm getting the service. They have, at the moment, over 1,000 customers, and they have a single machine for this, for over 1,000 customers using Redis service. Actually, they have another machine for replication, another one for staging, but it's only one machine, enough for all this for this memory needs. If you are using the memory in an efficient way, you are not going to store that many things. With 1 giga of data, you can store records for millions of users. No trolling. It's 1 giga, so of memory. You don't need that much unless you are Twitter. But if you are Twitter, you don't have trolling. But Redis is not always good. Sometimes Redis is evil. I like this part too, because it's like, oh yeah, Redis is amazing. I'm going to try it. Before you try it, Instagram. A few weeks, maybe 2 months ago, one of the engineers of Instagram was making a lot of noise on the internet saying, hey, we removed Redis from Instagram, and you know what? 75% reduction of the server's bill instantly. 75% when you are Instagram is a lot of money. Really, it's like, I don't know. So it's more than I can drink in a weekend, I can tell you. Why? Well, because basically, they are still using Redis for a lot of things, especially for background processing. But they were using Redis for everything, because this is something that happened. You are excitable, and I'm quite convincing, and I'm telling you, Redis is amazing, and I have a pirate hat. It's like, Redis is amazing, and this is cool. And you go home, and you start hacking with Redis, and you say it's amazing, and it's like, oh, I want to use it for everything. No. Use it only for what you should use it. Everything is in memory all the time. So these people were doing things like, we're storing all the historical information of the users, like, I don't know, abuse report. So when we are checking if a user is posting pictures with the name of another, blah, 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 we put everything there, and we are going to read it later, 2 weeks later. They were accumulating a lot of information. For that kind of thing, you shouldn't be using Redis. So just, use your head in case you have it, and know when it's not appropriate. More people that were doing Twilio. Twilio, I don't know if you know, it's quite amazing. Twilio is a nice company. They have Rails. They have a lovely API. The service is really, really cool. It's, if you don't know it, it's like for making phone calls, phone central, whatever. You can use it as a Skype. You can just call to someone from the computer, and they take money from your credit card. Except when Redis is failing, and they are blocking your credit card because they are trying to charge your card, but the server is not responding. So they try to charge again, and the server is not responding, and they try to charge again, and everything breaks, and people cry, and kittens die in the street, whatever. So yeah, basically what happens here, where they have this master Redis, and they have hundreds of slaves, and all the slaves started replicating to the master. The master couldn't handle the load for some reason, memory. They didn't have enough memory. The master stopped responding, and instead of doing the logical thing, let's go to promote one of the slaves to master or something like that, they did let's go to restart the master. But when they restarted, they were using an old configuration file And they started the master with a configuration that didn't have to do anything with the one that was actually in production. So you can imagine. So the other thing is, you need to know what you are doing. Because in Redis, you can do like quite hacky thing. You can change configuration on the fly. But if you change configuration on the fly and you don't persist the configuration to the config file, when you stop the process, you lose your configuration. Bad. So you have to be careful. It's like, OK, Redis is powerful, great power, great responsibility, whatever. And you might be telling me, OK, this is fine for huge sites, Twitter, Pinterest, but I'm a small guy. Can I use also this for my project? Yeah. How we are using Redis? First, for example, in the past, when I was young and beautiful, like you are now, most of you anyway, I was using Sidekiq or Resque only for sending to the background the things that I wanted to execute in the background. Call me weird, but I was sending only what I needed. But when I realized Redis is so fast, what I'm doing now is every time anything happens on my application, anytime a model changes, it's remove, it's insert, it's update, whatever, I put the change into Sidekiq. I send it to the background, just that information, even if I'm not doing anything with the information. So, for example, when we are creating a user, I send it to Sidekiq, and a worker takes the information, hey, new user, let's go to send an email. Perfect. When I'm updating a user, I send the information to Sidekiq. The worker says, hey, user was modified. I don't need to do anything with that. Discard it. But I'm sending all the information to the background. This way, if I need in the future, if I need to introduce any behavior on my application, I don't need to change anything. I can decouple the system totally. So basically, why are you doing this? Because we can. Since it's so fast, I send the information to Redis. It's there not even 1 second. The worker is going to get the information. It's like, I don't need this for anything. OK, that's it. Out. But you can instrument your whole system because it's for free. It's like, if imagine you could put logs of anything, and then you could put hooks to the logs in your system. You can do that. So do it. Why not? Because the design you're getting from this, you get everything so decoupled, then it's quite easy to separate things into services. For example, by doing this, all our notifications, webhooks, WebSockets, whatever, are reading directly from the Redis queue because everything is there already. I don't have to change my code. And I can, I can change the way I notification, and my main application is never going to know. So that's quite interesting for me. We're using Lua for some things. In Redis, you can expire keys. Like, OK, you can set this value and expire in 10 minutes. But if you have a hash table and you have attributes in the hash table, you can't expire an attribute of a hash table. Can you imagine? I want to expire an attribute in a hash table. I can't do that with Redis, OK? But I want to do it, but I can use Lua. So if I want to expire attributes here and Redis is not giving me that functionality, I program that functionality into Lua, and I'm using it. Cool. Or another thing, I'm pushing a value into a list, and Redis usually will push the value into the list because I'm telling you push the value into the list. But with Lua, I'm saying push the value into the list, but first I check if in the list, like imagine this is Instagram and someone is commenting, or this is Facebook and someone is commenting on a photo, and you will get a notification. Hey, Javi commented a photo, and I comment the photo again later. I don't want a notification. Javi commented this photo. Javi commented this photo again. Why? I mean, I only want the last one. So that's the thing what I'm doing with Lua. I'm checking, is there in this list a notification for the same user, for the same object that is still not read? If you have that, don't insert this one. So I'm moving that to the Lua layer. And the good thing is I can use this from different processes, one in Ruby, one in Node, and it works because it's in Lua, the functionality. It's not on my main application. That's kind of interesting. Also, you can paginate a list in Redis by index. Give me the first 10 elements from the 11 to the 20, whatever. But you can paginate by an attribute. So if you want to paginate by attribute, like for ID, I can do it with Lua. And in Lua also, you can parse JSON. So if you are putting JSON values, you can, read JSON or set JSON directly from Redis, which is also, quite fun. Counters, I told you before, you have counters. And the good thing about counters is I can put a counter, and I can set an expiration time, but if I change the value, the expiration time doesn't finish. So I can tell, OK, visits of this user. Record all the visits and expire in 2 minutes from now. So increment the counter. So I'm incrementing the counter, and the time is still, expiring, like moving. So the thing is, if you want to implement API quota pattern, for example, if someone is trying to access the API more than 200 times per minute, I don't want him to, to keep working with me. I only have to set a counter starting 0, expiration 2 minutes, start counting. At any moment, if it's still available. And if it's over 200, I'm not going to let you any other operation. After 2 minutes, I'm going to reset the time automatically. So, with counters and expiration, you can do things like API quota usage pattern in one line, which is like, and from different, like everything concurrent from different servers is like, wow, really, the kind of things you can do when you know what you are doing, even when you don't know what you are doing, like me. You can store, well, this is like the thing of the temporary data. It's nothing new, tell you the truth. So I'm going to pass this one fast because lunch is soon. Bloom filters. Bloom filters is one of these amazing things in which basically when you need to ask if I have a value in a set of values, like imagine something crazy, like I have usernames. I want to know if the username is unique. What I'm doing in Rails is validate uniqueness of. Cool. It goes to the database, it makes a query, blah, blah. That can be slow. So a Bloom filter, it's an structure in which you can ask, is this value already in the set? And it's going to tell you, well, if the value isn't there, it's going to tell you, OK, no, the value is not here. So it's unique, you can insert. You can have false positives. It can tell you, no, the value is here, and then you have to go to the database and check again. But the thing is, you have like a really, really efficient memory structure in which you can ask these things. So in our case, when we are trying to check the uniqueness of usernames, we are not going to the database. We are just using a Bloom filter. And this is possible because in Redis you can do like, bit operations, and Bloom filters are based on bit operations. So it's like quite interesting structure. And there is a nice gem for working with Bloom filters from Ruby, so you don't need to do anything. Just insert values in the Bloom filter and ask, is the value in the Bloom filter, yes or not? And you get like really, really, really fast test of if something is in a set or not with really low memory, which is quite interesting if you have that kind of problem. And the last one is this the last one? Yeah, it's the last one. And the last one, if you have Nginx, from Nginx, you can directly use Lua scripting. If you have Apache, from Apache, you can directly use mruby scripting with the modruby module. That's really hackish. Apache and mruby. So you can run scripts in Lua or in Ruby on your web server directly. And since from Ruby and from Lua, you can connect to Redis, you can do things like, OK, from Nginx, imagine in your application you are setting something in the cache, or the API quota or something, and you set that on your application. And from your web server, you can talk directly to Redis. So if something is in the cache, or if you want to read a value, you can do that on the web server layer. So for example, the API quota, you can check it on the web server, and your Redis application servers will never have to, if someone is trying to abuse your API, you can stop that at web server level, talking directly from Lua to Redis. So your application, if someone is trying not to hit you like too many times, your Redis application it will never know about that. If it's like too low level for you, you can also do it at the rack layer. It's this project, Redis Store. It lets you do things with Redis in rack before it hits your application. So it's also like quite interesting. So these are the kind of things you can do. This is the kind of things we are doing. And these are good for every project, not just for Twitter. Your application, they can be useful too. So to summarize, Redis is more powerful than it seems. It's quite fast. It's really easy to use. The commands, you saw, they were like quite easy. And the documentation, it's very good too. Everything is in memory, so you can think of this as, distribute data structures. It's really good as a data store, as an intermediate data store, like, for offloading charts from other stores, as a cache or as a queue. These are 4 common patterns, and Redis is designed for that. So you can use it in any of that. You can use it in huge and small systems, and the most important part is like you should probably start using it. So thank you for listening to me. If you have any questions, I will be glad to answer. And that's shameful self-promotion, but a man has to eat. So thank you.